So hi everyone, my name is Himanshu Kumar with my friend Somen Mandal, MTech Signal Processing and Communication. We are here for the video description of DreamGaussian, a framework for generating high quality texture 3D model efficiently. I will briefly explain the abstract behind the project, key innovations like Gaussian Splatting and Score Distillation Sampling, and give you a quick walkthrough of the code, implementation and supporting dependencies such as CUDA and other tools also. So as you can see here, this is the specimen that we have took, the Konark temple wheel, and this is not only the 3D structure that we have obtained, there are multiple. Going through the project overview, as its code, DreamGaussian tackles the slow per sample optimization problem found in traditional 3D generation method that use Score Distillation Sampling (SDS). Here's the abstract in short that I'm trying to say here. What is the problem? The problem states that existing SDS based method produce great results using 2D diffusion models, but they are very slow for generating each sample. Solution: DreamGaussian introduces a generative 3D Gaussian splatting model. Model represents the 3D scene as a set of Gaussians, each defined by its position, scale, rotation, opacity, and color. We have tried to implement in Google Colab because we are not having the compatible GPUs with the PyTorch that is required for doing this. So there are certain definitions that I am supposed to tell you before starting this. That is, first, the differentiable Gaussian Rasterization that we have took it. What is this? This technique renders 3D Gaussians to a 2D image in a differentiable way, so gradients can flow back to optimize the Gaussians. Diffusion model torch 3D. This is one that we are using. Remember that we have to take out that it should be compatible with the same. CUDA is NVIDIA's platform that accelerates computation on GPUs. PyTorch relies on CUDA to speed up the tensor operations vital for training deep models. So certainly, what is Gaussian splatting? That we are supposed to use a representation method where the scene is composed of many small 3D Gaussians that splat their contribution on the 2D image plane. This allows smooth gradient based updates for generating 3D content. Also, while doing this, we are generating some wheel files. You can see during this. In Python, a wheel is a pre-compiled package that simplifies the speed of the installation of dependencies without needing to build from source every time. Okay, so let's go to the code implementation and highlight this whole thing. This is a repository setup and a dependency installation. So you have to clone the repository and install essential libraries. Standard dependencies like INOPS, transformers, diffusers for deep learning, 3D processing tools such as trimesh, PyMCubes for mesh instruction, additional tools like NVDiffRest for differentiable rasterization, and QKit for rendering. Then after that, you have to go for the image uploading and pre-processing. The image is stored in a dedicated data folder, displayed ready to be processed. It will be. I will suggest that you should make a virtual environment before making this if you are trying to if you are using your GPU at the same time. Then the stage 1 comes here. Stage 1 comes. Training is done in the main.py file. What this main file is doing, I will explain it. That is actually doing the generative Gaussian splatting. What is this? So generative Gaussian splatting is something script. We initialize a set of 3D Gaussians, optimize them using SDS loss guided by a pre-trained 2D. SDS loss is defined as SDS loss. You can get it here. You can find the main file here. This refines the parameters of each Gaussian until the 3D structure begins to emerge. Once stage 1 is completed, we extract a mesh using local density queries and the PyMCubes algorithm. Then the UV texture is refined through a second optimization stage using a pixel-wise MSE loss. Then the rendering is done. Finally, we render the mesh and generate a video using QKit, letting you see the finished 3D model. In action. We have generated this OBJ file in the end of the day. So as you can see, the finished this 3D model is not as good as we have thought. Certainly there are other applications who give a very good rendered image. So this also includes with the OBJ file and albedo file that gives the texture of the same. To sum up, DreamGaussian leverages differentiable Gaussian rasterization and diffusion models with CUDA acceleration to generate high quality 3D content wraps. And thank you for watching this brief overview of DreamGaussian.